So we're excited to find that this sponge requires very little oxygen. And this is challenging the way we think about the origin of animal life on Earth. It's generally thought that animals, like this sponge, couldn't exist at all until the amount of oxygen in the atmosphere became relatively high. Before this rise of oxygen, you can't have animals at all. And while this idea is very popular, it was never really clear how much oxygen exactly early animals needed. So given that, we studied this sponge here since out of all the animals that are alive today, sponges are probably the most similar to the earliest animals. So by determining the oxygen requirements of modern sponges, we can infer the oxygen requirements of the first animals. So we collected this sponge right outside the lab from an environment with a lot of oxygen and put it in this experimental setup where we can control the amount of oxygen it's exposed to. So in this setup, we lowered the oxygen concentration, mimicking the ancient oceans with respect to oxygen content, and we observed its overall well-being, its ability to feed, its respiration, its breathing of oxygen, and also its growth. And we found that it can stay healthy at levels that are characteristic of the Earth prior to the origin of animals. So with respect to oxygen, there seems to have been enough oxygen in the environment to support animals before they originated. So this rise of oxygen wasn't necessarily a trigger for their origination. There could have been other environmental parameters or maybe some kind of biological innovations that were responsible for the timing of the origin of animals and not necessarily a rise of oxygen. So while we know that these sponges can tolerate these low oxygen concentrations, we're not sure if they can reproduce under them. So that's what we'd like to look at next, to see if young sponges can survive these low oxygen concentrations, grow into healthy adults, and then reproduce as adults. And in general, there's a lot we don't understand about the relationship between the amount of oxygen in the environment and early animal evolution. And this is just one part of that great puzzle.